Let us see Maths, Grade 6, Chapter 5, Prime Time, Subtopic Divisibility Tests. Learning Objectives. After this session, we will be able to determine whether a number is divisible by 10, 5, 2, 4, 5 and apply divisibility rules to solve mathematical problems. Introduction to divisibility test. It is easy to find factors of small numbers. How do we find factors of large numbers? For example, let us take 8560. How do we find 8560 factors? Does it have factors from 2 to 10, 2, 3, 4 like that? It is easy to check if some of these numbers are factors or not without doing long division. So today we are going to check how we are going to find this factors for the large numbers. First, divisibility by 10. Let us take 10. Is 8560 divisible by 10? This is another way of asking if 10 is a factor for 8560. For this, we can look at the pattern in the multiples of 10. The first few multiples of 10 are 10, 20, 30, 40, and we continue this sequence and we will observe the pattern. So if we keep on observing, we will get 50, 60, 70, 80 like that. What we are observing here, this multiples of 10 are ending with a 0. Is 125 is a multiple of 10? No, the answer is because it is not ending with a 0. But 120 is a multiple of 10. Will this number appear in the previous sequence? No, because this is not multiple of 10. So it will not come in this sequence of this multiples of 10. Now you can answer. Is 8560 is divisible by 10? Yes. Numbers that are divisible by 10 are those that end with a 0. Do you agree? Yes. So, therefore, for example, 100, 2010, 2020, 5670. If we observe, all these numbers are divisible by 10 because these numbers are ending with a 0. Divisibility by 5. The number 5 is another number whose divisibility can easily checked. How do we do it? Explore by listing down the multiples of 5. 5, 10, 15, 20, 25. What do we observe these numbers? Here, what we are observing is the numbers are ending with either 5 or 0. Do you see a pattern in this last digits? Yes, the pattern is either 5 or 0. So what is the largest number? Less than 399. That is divisible by 5. As we have seen in the previous, the pattern should be either end with a 0 or 5. If you consider the ending with this 0, 390 and ending with the 5 is 395. But what is the question asked? Largest number. Between this 390 and 395, which is the largest? 395. So the answer for this one is 395 is the largest number, less than 399, that is divisible by 5. And is 8560 is divisible by 5? Yes, because the number is ending with a 0. Let us consider this statement. Numbers that are divisible by 5 are those that end with either 0 or a 5. Do you agree? Yes, do agree. Divisibility by 2. The first few multiples of 2 are 2 1s are 2, 2 2s are 4, 2 3s are 6, 8, 10, 12, 14, 16, 18, 20. What do you observe here? If we are observing here, the number is an even number ending with this 2, 4, 6, 8, again 0, 2, 4, 6, 8 and so on. Here we are observing the pattern 2, 4, 6, 8, 0, 24680 are repeating 24680. Next it will come as a 22, 24, 26, 28 and 30. Is 682 is divisible by 2? Yes. Answer is because it is ending with the 2. Can we answer this without doing the long division? Yes, because as it is ending with the 2, this is. Is 8560 is divisible by 2? Yes, because it is ending with the 0. Here we have observed, right? The numbers ending with the 24680 are divisible by 2. Therefore, as this number is ending with the 0, this is number is divisible by 2. Consider the statement. Numbers that are divisible by 2 are those that end with 0, 2, 4, 6 or 8. Do you agree? Yes. What are all the multiples of 2 between 399 and 411? If we observe here, next to the 399, what is this number? Is 400. So, as 400 is ending with a 0, it is divisible by 2. Next, 402. Next, 404, 406, 408 and 410. Divisibility by 4. Look at the multiples 4, 8, 12, 16, 20, 24, 28, 32. If we observe here, all these numbers are even numbers and this numbers are divisible with this 4. Let us see, find the numbers between 330 and 340 that are divisible by 4. So here 332, 336 and 340. Here 340 also is included. Also find the numbers between 1730 and 1740, 2030 and 2040 that are divisible by 4. Here 1732, 1736 and 1740. Similarly, between 2030 to 2040 are 2032, 36 and 40. What do you observe here? If the last two digits are divisible by 4, then the number is divisible by 4. This 8536 is divisible by 4. Just now we came to know that this last two digits should be divisible by 4. So, as 36 is divisible by 4, therefore 8536 is divisible by 4. Consider these statements. First one, only the last two digits matter when deciding if a number is divisible by 4 or not. If the number formed by the last two digits is divisible by 4, then the original number is divisible by 4. If the original number is divisible by 4, then the number formed by the last two digits is divisible by 4. Divisibility by 8. Interestingly, even checking for divisibility 8 can be simplified. Find the numbers between 120 and 140 that are divisible by 8. Answer is 120, 128 and 36. Consider these statements. Only the last three digits matter when deciding if a given number is divisible by 8. If the number formed by the last three digits is divisible by 8, then the original number is divisible by 8. If the original number is divisible by 8, then the number formed by the last three digits is divisible by 8. Let us see. Questions. Figure it out. First question. 2024 is a leap year because as observed as 29 days. Leap year occurs in the years that are multiples of 4 except for those years that are evenly divisible by 10 but not 400. From the year you were born till now, which were leap years? Question B. From the year 2024 till 2099, how many leap years are there? Solution. If my year of birth is 2000, the leap years from 2000 to 2024 are 2000, 2004, 2008, 2012, 2016, 2020 and 2024. Leap years occurs every 4 years. So, from 2024 to 2099, the leap years are 2024, 2028, 2032, 2036, 2040 and so on till 2096. If we count these numbers, there are 19 leap years are there from 2024 to 2096. 1, 2, 3, so on will get as 19. Let us see question number 2. Find the largest and smallest 4-digit numbers that are divisible by 4 and also palindromes. First, palindrome is a number when we reverse the digits also, the number is same. For example, 121 is a palindrome because if the units place is reversing this one, then the same. 232 is palindrome. So largest 4-digit number is 9999. So last 4-digit palindrome is 9099 because even if we reverse also the same number will come. So the sequence of 4-digit palindrome in descending order are 9999 and 9889 and so on, 8888 so on. If we observe, these first digits are ending with a 9, so these are not divisible by 4. Therefore, (8,808) is the largest palindrome of 4-digit numbers, as well as it should be divisible by 4. Next, the smallest 4-digit number is 1000. The first 4-digit palindrome is 1001. The sequence of 4-digit palindrome in ascending order are 1001, 1111 and so on. So, the smallest 4-digit palindrome that is divisible by 4 is 2112 because we know that if the last 2 digits are ending with this divisible by 4, then the number is divisible by 4. Therefore, this 2112, this 12 is divisible by 4. Therefore, this is the smallest 4-digit palindrome which is divisible by 4. Figure it out. Question number 3. Explore and find out each statement is always true, sometimes true or never true. You can give examples to support your reasoning. Sum of two even numbers gives a multiple of 4. Yes, sum of even numbers gives multiple of sometimes true because 2 plus 6 is 8. As 8 we can write it as a 4 into 2 which is multiple of 4. But 2 plus 4 is 6. We can't write this as a multiple of 4. Second, sum of two odd numbers gives multiple of 4. Sometimes true because 3 plus 5 is 8. 8 we can write it as a multiple of 4. But 1 plus 5 is 6. We can't write 6 as a multiple of 4. So we can conclude that sum of two even numbers gives multiple of 4. Sometimes true. Similarly, sum of two odd numbers gives multiple of 4. That is also sometimes true. Let us see question number 4. Find the remainders obtained when each of the following numbers are divided by 10, 5 and 2. First one, 78. When the number is divided by 10, 78 divided by 10, then the quotient is 7, the remainder is 8. 99 divided by 10, the quotient is 9 and the remainder is 9. 173 divided by 10, the quotient is 17, the remainder is 3. 572 divided by 10, then the quotient is 57, the remainder is 2. 980 divided by 10, then the quotient is 98, the remainder is 2. 1111 divided by 10, the quotient is 111 and the remainder is 1. 2345 divided by 10, then quotient is 234 and the remainder is 5. Let us see this next page for this to check the divisibility by 5. The remainder obtained when each of the following numbers are divided by 5 are 78 divided by 5, then the quotient is 15 and the remainder is 3. 99 divided by 5, then the quotient is 19 and the remainder is 4. 173 divided by 5, quotient is 34 and the remainder is 3. 572 divided by 5, then the quotient is 114 and the remainder is 2. 980 divided by 5, quotient is 196 and the remainder is 0. 1111 divided by 5, quotient is 222 and the remainder is 1. 2345 divided by 5, then the quotient is 469 and the remainder is 0. Page turnover to check this divisibility by 2. The remainder obtained when this divided by 2, 78 when divided by 2, the remainder is 0 and the quotient is 39. 99 divided by 2, the quotient is 49 and the remainder is 1. 173 divided by 2, the quotient is 86 and the remainder is 1. 572, then the quotient is 286 and the remainder is 0. 980 divided by 2, the quotient is 490 and the remainder is 0. 1011 divided by 2, the quotient is 555 and the remainder is 1. 2345 divided by 2, the quotient is 1172 and the remainder is 1. Figure it out. Question number 5. The teacher asked if 14,560 is divisible by all 2, 4, 5 and 8, 10. Guna checked for divisibility by 14,560 by only 2 of these numbers and then declared that it is also divisible by all of them. What could be these 2 numbers be? Solution. To check if the number is divisible by 2, 4, 5 and 10, it is sufficient to verify whether number is divisible by 10 and 8. If a number is divisible by 10, it must be divisible by both 2 and 5. If a number is divisible by 8, it is also divisible by 8. Therefore, we can verify only with the 10 and 8. So, thus to check whether 14,560 is divisible by all 2, 4, 5, 8 and 10, it is sufficient to verify only if it is divisible with this 8 or 10. So, therefore, Guna might have checked only divisibility by 8 and 10. Question number 6. Which of the following are divisible by all 2, 4, 5 and 10? The numbers given are 572, 2,352, 5,600, 6,000 and this 7,76,22,160. First, we check this. Take the consider the 572. Divisibility by 2. When we are checking this one, as this number is ending with a 2, this is divisible by 2, and as the last 2 digits are divisible by 4, this is number is divisible by 4. This last digit is not ending with a 0 or 5. Therefore, this number is not divisible by 5. As the last 3 digits are not divisible by 8. Therefore, this is not divisible by 8. Similarly, the 10, as it is not ending with a 0, this number is not divisible by 10. Similarly, we have verified for this 2,352. This is divisible by 2 and divisible by 4, not divisible by 5 and divisible by 8, not divisible by 10. Similarly, 5,600. It is divisible by 2, divisible by 4, divisible by 5, divisible by 8, divisible by 10. 6,000 is divisible by 2, divisible by 4, divisible by 5, divisible by 8, divisible by 10. Similarly, the last number is divisible by all the numbers. The reason for each one, if a number to be divisible by 2, then the number should be even. If a number is divisible by 4 means the last 2 digits should be divisible by 4. To check the divisibility by 5, it should be either ends with the 0 or this 5. If the last 3 digits are divisible by 8, then the number is divisible by 8. To check the divisibility of 10, we are ensuring that one the number is divisible with the 10 if it is with the ends with the 0. Figure it out. Question number 7. Write two numbers whose product is 10,000. The two numbers should not have 0 as a units digits. Solution. Let us do prime factorization. We can write 10,000 as 2 into 5,000. Similarly, 5,000 we can write as a 2 into 2,500. 2,500 again we can split as a 2 into 1,250. 1,250 we can write as a 2 into 625. Similarly, 625 can be written as a 5 into 125. And this 125 can be written as 5 into 5 into 5. So, if we multiply these two all, 2 times 2 into 4 times, so we are getting as a 16. This 5 5 is a 25, 25 5 is a 125, 125 is a 625. So these are the two numbers whose product is 10,000 and neither of them has a 0 in the units place. Thank you.